So this is first derivatives test, some kind of example, number C. For some of us, if you look at this question, if you want to rewrite it just to kind of give yourself maybe a better look at what this is, instead of working with those negatives exponents, this is really 2 over x to the 1/3, or if you want to write it as 2 minus 2 over cubed root of x, maybe that's just a better way of looking at how that question started. And probably in a textbook question or a quiz question, we probably would have started with it as a radical like this and expected you to get back to 2 minus 2x to the negative 1/3. So in a sense, we kind of gave you a start on this question. Talking to a few of you, we're okay with the derivatives. Derivative of 2 is 0. Why not? We'll just show that for today. Negative 2 times negative 1/3 is hopefully positive 2/3. Oh, there should be a plus sign here. Plus 2/3 now. And go down by a degree. So this becomes negative 4/3. So a little bit of algebra. Negative 2 times negative 1/3 is 2/3. And then negative 1 from negative 1/3 is negative 4/3. I'm just going to clean this up a little bit. 0 plus anything, the 0 goes away. 2 is the only thing I have left in my numerator. 3 is my denominator, and I can write x to the 4/3 here. If some of you think radicals are easier to work with, you want to go cubed root of x to the 4th. That works as well. It means the same thing. The next thing you want to do is you want to look at your critical numbers. And depends again where you're kind of at and comfortable with your critical numbers. Critical numbers are 2 things. Where is your slope equal to 0, or where is your slope not defined? And we can look at the first one. If you try and make your slope 0, 2 over 3, and whether you use the cubed root of x to the 4th or x to the 4/3, that doesn't matter. If you cross multiply, if you want to solve, it's a rational expression, so cross multiplying is a neat thing to do. You get 0 equals 2. Is that ever possible? I hope not. So what you have to be able to interpret from this information then is the fact that if you try to say, where is my slope 0 at? And there's nowhere. So there's no place where your slope is 0. So if you start thinking about your number line, your regions, you don't ever have any place where your slope is 0. But the other thing we always have to consider is, where's your slope undefined? And the 2 things we talked about undefined is, do you have divide by 0, or do you have square roots of negatives? In this case, we have to consider the dividing by 0 scenario. And whether you look at the original function, and it's easier to see in the radical form, right here, you know that x can never be 0 because it causes dividing by 0 in the function. So your function doesn't exist at 0, and the same thing is going to be true in your derivative. X can never be 0. You can't find the slope where the function doesn't exist. So if 0 is not in your domain, 0 is not going to be a place where you define your slope. So there's no place where I have 0 slope, but I do have to consider where 0 is still. So I still have 2 regions to look at. So I want to do my table, because again, for me, my table just helps me organize my thoughts, but I only have 2 rows. I have my negative infinity to 0 row, and I have my 0 to infinity row. That's the only 2 I have, because I have 1 critical number. If I start looking at my derivative, I could put 2 in there. I could put 2/3 in there. That doesn't matter because they're positive numbers. If they were negative numbers, I would have to be more concerned about them. But just because it's the top, I'll put 2 in there, only because it's the top expression. It actually has no impact on the region at all. The other number I'm going to put in, I can just put x in here. I can put x to the 4th in here. I can put the cube root of x to the fourth in here. Let's go cubed root of x to the fourth. Then my third column is what kind of slope do I have? And then my fourth column is what's happening to my function. If you go back to your column, this is why the 2 has no impact on anything at all. 2 is always a positive number. Okay, so 2 is not going to have any impact at all on my function. And if you start thinking about your rules of exponents, take a negative number, cube root it, and go to the fourth, or take a number to the fourth and cube root it. What happens to all your numbers in this first region? They're also positive. Because as soon as you go x to the squared or x to the fourth, you get positive numbers. Positive times positive means my slope is positive, which means my function is increasing. Similarly, on the bottom, it's also positive, which means I have a positive slope, which means my function is increasing. Can you make the statement that your function is increasing from negative infinity to infinity? Is that a true statement, or is that not a true statement? Right? Is our function increasing from negative infinity to infinity? The answer to that is no. And the reason it's no is you can't have an increasing function at 0. Function doesn't exist there. So, no. Your function is increasing from negative infinity to 0. Union, you guys ever use these union statements? 0 to infinity. So what we're saying is that our function is increasing everywhere except at 0. So if we're going to justify if you have a local maximum, local minimum, look at your table, and a local maximum is supposed to go from increasing to decreasing. Increasing to decreasing is a maximum. We don't have that. Decreasing to increasing is a minimum. We don't have that either. So we don't have a local maximum. We don't have a local minimum. In fact, we don't have a point there. So grab your calculators and just sketch the original function and justify that your math is true. So graph 2 minus 2x to the negative 1/3. And what you want to see is you want to see the functions increasing from negative infinity to 0, and that the function's increasing from 0 to infinity. And there's a vertical asymptote where x equals 0.